Hello, Mario. In this video I'm going to take a look at reducing some information that we collected in the field today. We went out and did a few readings with a Sakisha level and did a variety of things, and we encountered a few little points that require clarification before we sort of carry on with this. So just thought we'd try and clarify a few things. So first of all, let's just look at this first one here, which is just we started at nail OR, we had one change point and went to aluminium plug KB. Then instead of coming back via the change point, we just came directly back. So here we are. First up, took our back sight 0.302 on nail OR, foresight 1.244 on change point 1, and we should be able to work out that that is a fall. Remember that we first of all start with the back sight and subtract the foresight from it. If it's a negative, then it's a fall. But we don't show it as a negative, we just show it as a positive, because falls are automatically negative and rises automatic positive. So that's our first setup. Then our second setup, we took a back sight on change point 1 and a foresight on alloy plug KB. And again, we input our back sight, take the foresight away from it. In this case it's a positive, so that's a rise. And then we just went directly back. We didn't just took two long shots back. So we just took a back sight. Remember, the first shot of any setup of the level is a back sight. And then we took a foresight to the nail we started with, nail OR. Okay, we input the back sight, take the foresight away, we get 0.841, that's positive, that's a rise. One way of looking at it is if you're seeing more of the staff at the foresight, that's a fall. Because you're seeing more of the staff, the ground's falling away. If you're seeing less of the staff is rising, that's a rise. Okay, so now we've come from our start point to our finish point. It's a double level run, and we start with our raw level 100.000, assumed datum RL 100 on the nail OR. Okay, just sort of started with 100, it's convenient to use. So we add our rise there. We subtract our fall, 100 minus 99.058. Then we add our rise, 99.157, and then we add our rise, 0.841, gives us 99.998. But hey, we started at 100, so we've lost a couple of mils along the way, 2 millimeters, and that's what we call our miss close. So straight away we can put our 2 mils in here as an total adjustment, and we can make that 100.00 because that's what we know. So now we've got this 2 mils adjustment, and what we do is we accumulate the adjustment, so that, because if we add a millimeter here, we've got to add that millimeter all the way along. So essentially there's no adjustment here, we're going to have a millimeter adjustment there. So we've added a millimeter between there and there. We're going to put no adjustment in here, so we keep that as 1 millimeter, and then we'll put another millimeter between here and here in this setup here, and that gives us our 2. So there's our adjustment done. It accumulates, it starts, and it gets bigger and bigger and bigger till it builds up to the total, which was 2 mils. Then all we have to do is just add across 99.058 plus 0.001, 99.157, and this gives us our reduced final levels to the millimeter. Later on it may transpire that we would round those perhaps to the nearest centimetre or 2 decimal places. Remember, I'm using an Excel spreadsheet here, always keep the original field notes so that you can go back and have a look at them. Now, some of the important things to do are the arithmetic checks, or check on the arithmetic. So these readings in here, they can't change, but you could get some arithmetic errors. So what we do is we add up all the back sites, 2.932, and we add up all the fore sites, 2.934. Now in this case, because we've started at one point and finished at another, we know that they should be equal, and they're out by 2 millimeters, which agrees with what we got over here. We add up all the rises, add up all the falls, and again they're out by 2 millimeters. Now that tells us that in this case the rise and falls tells us what our misclose is, and also, well, both of them tell us what the misclose is, but because it's the same in both instances, it tells us that there's no arithmetic errors in what we've done. Everything, our arithmetic is good. So that's just that little one there finished, and the purpose of that is we've established a level at APKB. Now this is just the same scenario, but a different group of people have done it, and the difference here being that we came back via a different change point. So we went from nail OR to change point 1 to APKB, and then back to change point 2, and then back to nail OR. And again, this time we got 5 mils, so we adjusted out the 5 millimeters. Again, it's cumulative, so I put 1 millimeter here. I'll just we put 0 in there just to sort of keep it consistent. Okay, 0 in there and 1 there. I put 2 millimeters in there, 1 millimeter in there, 1 millimeter in there. There's a sort of we've got 1, 2, 3, 4 setups and 5 millimeters to distribute, so we can have 3 lots of 1 millimeter being the difference between here. So there's 1 millimeter in there, 2 in that gap, 1 in there and 1 in there, but it accumulates to a total of 5. So all you have to do is build it up and accumulate. Remember, it's per set up, so if you have intermediate shots, what we're going to look at next, the correction or the adjustment to any of the intermediate shots would be the same for all the intermediate shots from the same setup. So there we come through and we can reduce out our things there. Once again, we check our back sites and fore sites and we get the same difference, and that's also equal to our misclose there, which I've just shown down there. These are the sums and across here. Using an Excel spreadsheet, it's a really good way of, I like to do them in Excel spreadsheet. You can do a lot of the arithmetic with them using all sorts of conditions and things. You can sort of speed up your time, but always keep the original field notes, original in the field notes. They should be dirty, they should have crossouts on them. You know, they might show that they've had a bit of a hard life, but at least that tells us they're original. So, and just thing to note here, in this case, this group got 99.158, this group here 99.160 for the same mark. So, you know, fairly consistent sort of work there. We can be fairly happy with that we're within a couple of millimeters for height, which if you just hold your fingers out and try and keep them 2 mils apart, you know, it's not very much, but pretty good under the circumstances. So just moving on to the next one, what we did next was I'm just fixing up intermediate there because I spelt it wrong in there. Now this one here, what we've done here is we've started with the nail KB from the previous one, which we worked out had an RL of 99.160, and then what we've done is we've picked up some levels along a little piece of road, and these are all intermediate shots, which introduces a sort of a different dimension to how the things work. So first of all, what we did was we did a back sight to nail KB 1.690, and then we did a series of intermediate shots, firstly to survey nail 02 at chainage 0. These are the chainages here, and we did the various chainages 5, 10, and then we had the start of a speed hump here, the middle of a speed hump here, the end of a speed hump here, and then 15, 20, 25, 30, and survey nail 3 at chainage 33.46. So we just did little intermediate shots to each of those. Alright, and remember that. So we did our back sight, then our intermediate shots, then we did a foresight to nail KB2, okay, which is another control point. So that's all good, and we got 1.248. Now we're doing a double run leveling, so we went there, and we also wanted to go back just as a check. So we want to have a good check on things. Now, so what we did was we moved our instrument slightly, or maybe up and down or a little bit, and we took a back sight to nail KB, which hasn't moved, hopefully, and we got 1.259. Now, and then we're going to just go back through all of the intermediate marks again. Now, the thing to note here is that if you look here, 1.259 is about 11 millimeters higher than this foresight here. So what you would expect is that all the intermediate sights will be approximately, and the intermediate sights are sort of at a lesser accuracy than change points and the nails or the control points like nail KB and KB2 and what have you. So they should be approximately, so that's something just to keep an eye on as you're doing these, because if you get one of these intermediate shots wrong, it won't affect the answer, because it doesn't affect the actual the level close, but it will affect the values on all the intermediate shots, because it'll affect the ones after and around it. So it's a good idea to keep an eye on those and make sure they're around about 10, 11 or 12, you know, 9, 10, 11, 12 mils sort of up. So like that one's 1.41829, there's 11 mils there, 11 mils there, 1.597, 587, it's only 10 mils, 1.65, 11 mils, 11 mils, okay, and so on all the way through. So we've done that, and then when we get to the end, we take a foresight onto nail KB, which we note is 10 mils up on the back sight to nail KB, which again is that 11 mils thing. So very good to watch. So that tells us that we've got some pretty good stuff going on there. Now then we go through and just work out our rises and falls. Now it's usually we start this, we take this back sight here and subtract the 1.809 from that. That gives us a fall of 0.119. okay, and then we just work out all these rises and falls, just taking inputting the one above and taking the intermediate shot below all the way through and working out our rises and falls. Then we come through to our this one here, just take off the intermediate, input the intermediate shot, take off 1.248, and as we can see there, we're getting a fall, sorry, a rise there, because we're seeing less of the star, and so on. So we work out all our rises and falls just as we've done, and then of course we can work out all our raw levels all the way through. And in this case here, we've got a misclose of 1 mil, 99,161. We started with 160, so we've got 1 mil to subtract. Now the thing is that all the intermediate shots of a setup, remember that a setup involves a foresight, the intermediate shots, and then the back sight. So all of the intermediate shots should have the same adjustment on them, because essentially you've back sighted, so for instance in this case here, nail KB, you've applied no adjustment into there, so you shouldn't apply any to any of the intermediate sights in theory. But with small errors like this, it's probably not going to make any significant difference. and then we've pushed 1 millimeter into everything from the second setup there, like so, and that that gives us the our result that we've got there. Something to check out, of course, is that these are the same points. The reason we do it twice is to check it. So SN02, we've got 99041, 99040, 99083 on that, and so on. So we need to check those through. Where we get slight differences, what we would do is mean them. We would probably show our final levels on any plans, just be rounded to the nearest centimetre or something like that. Now let's not forget our arithmetic checks down the bottom here. So add up our back sights, add up our foresights, there's our mil there. Add up our rises, add up our falls, there's our mil there. We know we've got a mil there from the start to the finish. So that's all our arithmetic checks done. It's all very good. And we've got a misclose of 1 mil, which is quite acceptable. We'll look at miscloses and what have you in another video. So there you go, just a bit of a heads up on reducing and some of the aspects of some of the work we've done out in the field today.